Now that we learned about nested iteration, let's go back to an example on calculating the mode of a list of numbers. So the mode is the number that occurs the most in the list. So in this case, the mode is going to be 9, which is what we expect our program to output. So again, we declare an array of numbers, and we'll look at this in more detail later on. But we visualize this array as a list of numbers that can be indexed starting from index 0. And here we initialize our mode to be 0, and we have a counter that's going to count the number of times that a number occurs in the list, and a previous counter to store the previous count that we're going to compare against. So when we enter our for loop at I equals 0, I is less than the length of the list, so therefore we execute the code statements inside this for loop. And we initialize our counter to be 1, and then we enter our second for loop, which we start iterating at the number after index I. So effectively in this case, we have j is equal to 0 plus 1, which is 1, and 1 is less than the length of the list, so we execute the statements inside this for loop. So here we're effectively comparing the number at index 0 to the number at index 1. And if these were equal, we'd increment the number of occurrences of the number at index I. But in this case, 2 and 4 are not equal, so therefore countNum does not get incremented. And then j gets incremented to 2, and this process keeps repeating. So as we can see, there's no number in the list that's equal to 2, so countNum is not going to get incremented, it's going to remain at 1, until this loop is terminated when j is equal to the length of the list. And when this loop gets terminated, we compare the current counter, which is 1, to the previous counter, which we've initialized to 0. And given that this is true, we set the previous counter to the current counter, and we set the mode to be our number in the list at index I. So in this case, our number is 2. And then I gets incremented to 1, and 1 is less than the length of the list, so we proceed to execute the code statements again under this loop. So again, countNum gets reset to 1, and this time we're comparing the number at index I equals 1, which is 4, to all the numbers after it in the list. So again, the number at index I being 1 is compared to the numbers at index j is equal to I plus 1 onwards, which is the remaining numbers in the list after 4. So given that this is always going to be false, countNum does not get incremented again. So therefore countNum being 1 is not greater than the previous countNum, so therefore prev countNum and the mode do not get changed. And then we proceed to iteration I equals 2. So we're comparing 5 to all the numbers after it. And again, 5 only occurs once, as we can see, so prev countNum and mode do not get changed. And then I is incremented again, and this time 7 occurs several times in the list, so as we can see, the number at index 3, being 7, is equal to the number at index 4 and 5. So therefore countNum in this case is going to be incremented twice from 1. So it's going to be equal to 3. And given that countNum is greater than the previous countNum, which is 1, then prev countNum will be set to countNum, which is 3. And the mode is going to be set to the current number in the list at index I, being 7. And this process continues until I is equal to the length of the list, where we exit the loop and then print the mode to the screen. So we can see that 9 occurs the most in the list, so we expect the mode to be 9 and that's what will get output to the screen.